we had was a client, which could be a personal computer, it could be a tablet, it could be a phone. And the application we had running on it was a web browser. And we had a server that was somewhere else on the network. And the application we had running on it was a web server. The web server talked to either a file system or it talked to a database. In your assignments, yes sir?
The camera's not getting you.
The camera's not getting me?
No, it's like, I think pointed upward.
Really?
Yeah, it's not even getting the board.
Thanks. Uh-oh. Is that better?
Yeah.
All right, thanks. Appreciate the help. And we talked about how the 4 parts of the class this quarter are the web design, the network between the two, the database, and programming. And the particular type of programming we're doing is JavaScript. Again, over here on the web browser side of things. Those are the 4 parts of the class. Now, we're going to cheat a little bit. And I don't have a good excuse for this, but this is how it's going to work in this class. The reason we're doing this is because modern web applications are all moving to the web. And the web browsers, especially in a mobile environment, are getting to be more and more capable. So as you learn JavaScript and you learn web design, combining that with a database and understanding the databases, you're going to be doing a lot of application development in that environment. It used to be that you would write applications that run on the client, and they would stay on the client. Applications like Photoshop or Word, traditional applications like that. These days, many applications are moving to this distributed model, what they used to call a thin client and a server. Now, unfortunately, in order to do this on the website, there's typically a piece here that some people call an application server. Things like Cold Fusion, things like Tomcat, which is a Java-based engine, things like Ruby on Rails or PHP frameworks, or that sort of thing. We had to stop somewhere in course design. We're trying to figure out how can we show you all of this without muddying up the situation, so we don't. So when I say this whole thing plays together, it kind of plays together. You still have to learn how to do databases, and we're going to be spending the next 3 weeks on that. But we're going to be using a database application over here. That's Microsoft Access. And if you go further, if you take the classes on web development, like there's a PHP sequence here, if you take the classes on Microsoft Technologies, ASP.NET, or if you take the classes in Java, you'll learn all of these pieces, all of how this works. But this is an introductory class, so we're going to keep it kind of simple. I say simple, and you can almost hear the quote marks around that word because nothing's simple. So, you're going to learn databases, and you're going to learn the theory of databases, and you're going to learn the how to design a database, how to design the forms that you use for interacting with the database. You're going to learn all that sort of stuff. You're going to use Microsoft Access to do it. Now, if you end up never doing IT, if you never end up doing this sort of thing, that's fine too, because a lot of people use databases in office environments and plenty of different environments, and Access Access is very popular. It's part of the Microsoft Office suite, the professional Office suite. There are other ones around there, like if you're on a Mac platform, there's a popular one, the name escapes me right now. There's a bunch of available on Linux, but Access is a decent application to learn. If you were on server side of things, you'd be looking at Microsoft SQL Server, or you'd be looking at MySQL or PostgreSQL, Oracle, or who knows how many other things. What you learn in our database segment in the next couple of weeks will apply on either side. Okay? So that's where we were last week. That's where we were last week. Hi.
Hi.
What's the name of the web server where you are going to be putting your stuff? What's its address? Great. Has everyone had a chance to go visit sws.pcc.edu? Have you had a chance to go there? So you're going to be putting your folders here. Now what's interesting is desire to learn is in fact one of these things. I'm not sure what it's written in. It's probably written in Java. I don't know. But desire to learn is one of these things. Desire to learn. It's called a learning management system, an LMS. And there are other learning management systems out there like Blackboard or Moodle or any of the other ones. If you're in the school business, desire to learn is one of the big things, and it's got the same thing. It's got a big database running underneath it, probably Oracle. It's got a bunch of code that actually implements desire to learn, and then it's talking to a web server. I'll bet they're using Apache. We don't actually put desire to learn on our machines here. Desire to learn lives in a cloud on the East Coast, as far as I can tell. And you can tell it lives on the East Coast because everything significant happens at 9 p.m. Whereas most IT departments will try and put things after people go to bed. With desire to learn, everything happens at 9, and we're always pushing the stuff back into 10, 12. So anyway, desire to learn is somewhere on the East Coast. And all of us get through that to some number. All right, so you have to put your stuff on the file system on SWS. You'll notice in the example, or in the assignments, that we tell you exactly where to put things, and exactly what to name things, and exactly how to arrange things. Some things are private and some things are public. If you don't do it exactly like I ask you to, I'm going to take off points. This is kind of foolish and childish, but that's who I am. In fact, the reason I'm doing this is because that's how computers work. When you get to programming, if you want to get your code to validate, you have to be accurate to the character. Each letter of every word has to be correct. And it's one of the things about learning how to be in software, is that you just have to get that into your way of thinking. You just have to adopt that attitude. And so I'm taking that attitude from the beginning. If you don't get it right the first time, you'll have to get it right the second time. Every week your code has to validate, your HTML has to validate. We had a question earlier on, does your CSS have to validate as well as your HTML? Now you'll notice that the assignment requires that you validate with 0 errors, and you put a little badge on your page that says I validated. That only has to be the HTML validation. I would encourage you, however, the reason we do that is because of the first few assignments you don't actually require CSS. We don't need you to use CSS. Later on, you're going to start using CSS, and then you're going to move your CSS into an external file, and you're going to play with CSS. But the assignments are written that you only need to validate your HTML. When you start adding CSS to your file, and you start adding JavaScript to your file, it can confuse the validator. So one of the techniques you'll have to learn later on is how to keep your validator happy, and keep that thing validating, even if there's stuff in there you don't care about. One of the problems with JavaScript is it doesn't complain a lot. There are some languages like Java or C# that really help you a lot. If you do something wrong, if you write something incorrectly, they will tell you. And they'll say, no, you got this wrong. Oh, then, right when you're compiling. JavaScript is one of those languages that fails silently, which is a nasty, nasty, nasty thing. Because what will happen is if you write your code incorrectly, nothing will happen. And it will give you no help to figure out what went wrong. Whereas some of these more advanced languages like C# or Java will help you because they're strongly trying to be a better development. One of the things we'll show you today and we'll use throughout the course is how to use a debugger to find problems. Okay? So here's the sign-in sheet. As I said at the top of the class, we're going to try and get out of here a little earlier tonight. The campus is closing at 6, and I'm supposed to make sure you folks are all gone by 5. We'll get a little head start on that. As far as I know, all the snow will be gone Thursday, if not tomorrow. Has everyone signed up to be on the weather alerts? You can go to mypcc.edu or go to pcc.edu and look up weather closures. There's a way that they will send you the alerts to your phone. What's unfortunately is usually they send you those alerts to your phone an hour after they actually happen. Yes, sir. Thank you. Hold on a second.
Actually, campus is closed at 5.
Pardon me?
Campus is closed at 5.
Yeah, I want to get you out of here.
Okay.
They're going to come through and sweep the thing at 6 and kick everybody out.
Okay.
Yes?
It's called Flash Alert.
Flash alert. Yep. I got an email from PCC at 2 o'clock telling us what we just discussed. And I got the flash alert at 4. But at least, which actually happened after I drove here. So that has actually happened a couple of times, that I hear that the campus is closed after I actually drive to campus. But
What happened when there was real snow?
I don't know.
Well, you log on to my PCC. This morning at 6 a.m. when I was up, they already had the Sylvania campus notification out there, all across the top saying open at 10. So you don't even have, if you just go to mypcc.com,
It's right there on the
that, yeah.
when you log in. That's right. And I got the notice that the shuttle system had shut down at what, noon?
Yeah.
Something like that. So during these periods of time, please log in frequently and we'll hear about the thing. As I said, you can do pretty well in this class. You can certainly get a B or better if you never show up. If you just read the assignments online. And we are getting better that everything is available online. The classroom experience is more for your benefit to learn stuff rather than just pass the quizzes. Okay, so getting back to the subject at hand. Take a break about 10 minutes. We said last time that when the web browser requests a certain web page from the web server, it uses a particular protocol. What's the name of that protocol? Pardon me? URL. That's the name of the resource it's looking for. What's the protocol? You can tell the protocol because it's right up front in the URL. http://sws.c. What does HTTP stand for? Who said that?
It's hypertext, and I don't remember what the second T was.
Yep.
Protocol.
Hypertext transport protocol. HTTP. Now there's another app that we're using in our class this time, and it's called FileZilla. What is this thing? What is this?
FTP.
FTP. So it's a way of talking directly to this file system. There's actually an FTP server here. FTP servers are usually built into the operating system now, so they're just built in. Now, as someone asked me earlier, with Internet Explorer, you can talk directly to an FTP server. So Internet Explorer is one of those web browsers that will do a half-decent job. of doing file transfers. Problem is, it does a half-decent job. The other problem is getting familiar with FTP is another one of those entry-level things. One of the things you do in IT departments is you move files around all the time. FTP is the grandfather of how this works. It's one of the oldest protocols around. It's still used a lot. There are more sophisticated ways of managing servers, but FTP is the starting point. So we'd like you to get familiar with FTP. That's one of the reasons, and we did this in CS 120. We wanted you to use FTP to move files back and forth. Later on, depending on how far you take this, you'll use things like Parrot, or you'll use the Microsoft server environment, and you'll be moving files back and forth all the time between systems, and it's just another thing that you've got to get familiar with, another thing that you can be good at. FTP is typically a security pole too, so whatever that's good for. All right, so that's the environment we're working on. You go get a web page, and it comes back, and it's got 3 parts. Does anyone remember the 3 parts we talked about? The first part is the HTML, and that's the structure and the information. What's the second part?
Behavior?
Yes, those are the 2 parts. So I heard CSS, which stands for, right, cascading style sheets. And the last part is the behavior. And that is, in our world, JavaScript. Style sheets are what we're going to pick up today. We're going to take a little step back and we're going to talk about the structure aspect of HTML. Remember, last time we talked that you had an HTML document. Inside that, there was always a head and there was always a body. We use lowercase here, body. And then inside the body, there was a tree structure where there was H1s, and then inside the H1s there was, or the same level, there were paragraphs. Every one of these, I'm not showing you the trailing tags, but every one of these has a trailing tag because it's XHTML. You could have something called a div. Does anyone know what div stands for? Probably haven't run into this before. We didn't talk about it in CS 120. A div is a general purpose container. It's just a way of organizing things. Here's an area of the page where I want to put some stuff in it. The neat thing about a div is you can name it. So if I wanted to name this section of my document warning, I want to make it red, and I want to have a particular style. Pardon me?
Sorry, does that say head? HTML to the right.
This is head, this is body. Then inside this div, I go down and I can have another H1. Oh, I was going to use an uppercase. My goodness, don't do that. H1. Key. But let's get a little more interesting. Inside here, I'm going to make a table. And a table has an interior structure. First, every table has what? What's the top row of a table called? The heading of the table.
The title.
And then what's the tag for using the, for making header cells? TR, no, TH. TH. And then inside the TH are TDs. TDs. And then each row after that is TR. And that has TDs, TDs, TRs. Each of those has TDs.
Does that say warning? Or
Yeah, that's just a name.
does it have to be all in capitals?
No, I just put it in capitals. I just decided that was my name for that div. The point here, you don't have to copy this down. The point here is that this is a tree structure. Doesn't look like much of a tree, but you're going to see tree structures in computing all the time. Computer programs are full of trees. HTML is based on a tree. Folders, file systems are made out of trees. Why are they called trees? Because there's always a root. There's always a root. These are all branches. And the important thing about a tree, this is a particular type of tree. Remember on the last time I said that everything has to nest properly. So, for example, if in this div I have an unordered list, and inside my unordered list I have a list element, another list element, yeah, spell it right, L-I-L-I. That this paragraph container can't mess up this thing. They have to be separate. So it's good to think of it as a tree, because that way you know that, well, I don't want my branches all tangled together. Each one of these has to stand by itself at this level. When you take this whole tree structure together, this thing is called the DOM. And it's not the darn. Doesn't make offers you can't refuse. It's called the document object model. The document object model. Now this is as deep as we're ever going to get in HTML. When you go back at the end of this semester and you start writing JavaScript that changes the appearance of web pages, and that's where it's at in terms of application development, JavaScript running in the browser, talking to one of these application servers in PHP or ASP.NET, all of these things, they are manipulating, they're changing this document object model. And every time you change this document object model, the web browser takes that document and renders it again. It draws it again. Every one of these things in this document object model, the body, the headers, the paragraphs, the tables, the lists, every one of those things can have a style associated with them. You can say, I want fonts that look like this. I want my headers to have these kind of fonts. I want my tables to have this kind of shading to them. The same stuff that you can do in Word or any other thing. So your cascading style sheets, they all know about this model. They all know about this tree. And then your behavior, your JavaScript, the stuff you write in your JavaScript changes this tree around. Now, when you look at an HTML page in a text editor, it doesn't look like this. It's just a bunch of text. And that can be confusing. It's hard to read code. It really is hard to read code. And as you learn programming, as you learn coding, you will find you spend as much time reading code as you do writing it. Because it's a skill that you have to pick up. It's just like if you were going to be a novelist, one of the first things they tell you is read lots of books. Because you got to read stuff before you understand how to write it. And you're going to be reading a lot of code. Well, it would be neat if we could figure out a way to take that text file that has all that gibberish in it and display things like that. It would be even cooler if we could figure out a way of taking that HTML and that CSS text file and actually see the web page change. Come back and forth and see the effects of our coding. So after our break, take a 5-minute break, we'll see how to do that.